an additional comment on the meaning of this derivative. Just as an example, if we evaluate a prime at 0.025, we get $10,000 times 1 plus 0.025 over 4 raised to the 39th power, which is 12,750. Now I want to suppress the dollar sign here, and I'll just talk about the meaning, because this quantity also has a meaning when you take the derivative, and I don't want to get into explaining that, except to say that a prime is the limiting value of a change in a delta A, divided by a delta R. You remember how we get derivatives. They're the limit of change in this divided by change in that. They're the limit then of a rate of change, in this case rate of change of the amount you get with respect to your interest rate. Okay, well, that rate turns out to be 12,750. Now 12,750 what? Excuse me a second. Okay. We got a bizarre message on the computer screen that distracted me. I had to take care of it to make sure that this video wasn't crashing. Okay, 12,750 what? Okay, A prime is 12,750 something. It's a rate of change of A with respect to R. Well, that's going to be in dollars. I just eliminated the dollar thing, but it's in dollars per unit of interest rate, okay? Because the DA is in dollars, change in A is in dollars, change in R is the change in interest rate. So we have dollars per unit of interest rate. If we change the interest rate by 0.01, increasing it then from 0.025 to 0.035, then we would expect an increase in our 10-year return to be about what? Well, the change in the rate is 0.01. The rate of change of our return with respect to our interest rate is 12,750. So we multiply the 12,750 by the 0.01, we get 127.50. Okay, that's 0.01 units of interest rate multiplied by the number of dollars per unit of interest rate, number of dollars change per unit of interest rate. So that we should expect to get approximately $127.50 more by choosing a 3.5% as opposed to 2.5% interest rate. Now remember, interest rate is really a decimal. Percent means per hundred. So an interest rate of 0.025 that corresponds to 2.5%. 0.01 corresponds to an increase of 1%. And 1 unit of interest rate would correspond to an interest rate change of 1 or 100%. Okay? And we're not changing our interest rate by 100%. We're changing it by in increments, probably around 1% or so. So there's our result. Now, just what would our return be for a 2.5% and then for a 3.5% interest rate? You can easily do the calculations. This A function evaluated for 0.025 gives you $1,283. Meaning $1,283, and evaluated for 0.035, $1,417. Now you would want to use a calculator or some kind of computer algebra to evaluate that. You have no good way of evaluating that by hand. Okay, and the difference here is $134. Now, the prediction we get based on A prime at 0.025 is $127.50, a little bit lower than the actual difference. And there's a reason for that. That's because as this number goes up from 0.025 to 0.035, the A prime keeps increasing. The rate of change keeps increasing, so that the actual difference ends up being a little bit more than the difference predicted just on the rate of change at 0.025.